I'm Matthew Sandoval, and this is Lab 1 Charge Tape.
Here are the 5 main parts of the lab.
The purpose of this lab is to determine, using the correct fundamental physical principles, how much excess charge is on one piece of charge-clear tape. The fundamental physical principles and models used in this lab are Newton's second law, the gravitational force on the Earth's surface, and Coulomb's law. Newton's second law allows us to determine the net force on an object using an equation derived from the equation for momentum. The gravity constant, which is used in tandem with Newton's second law, helps establish one of the forces acting on the charge tape. Knowing this force helps with computation and determining needed values. Coulomb's law, also called the electric force, explains the force between two electric charges. The force depends on the size of the charges and the distance between them. The force increases if the charges are larger or closer together, and it decreases if the charges are smaller or farther apart. Coulomb's constant allows us to determine excess and deficient electron charge later on in the experiment. Each of the required formulas are on the left side of this slide. In order listing is Newton's second law using the gravity constant, and then the electric force and Coulomb's constant. A quick preview of the lab results shows that the tape has a net positive charge, meaning it has an electron deficiency, a tape charge of 7 times 10 to the negative 9 coulombs, and it was deficient of about 4.3-ish times 10 to the 10 electrons. The process of this lab was pretty straightforward. The first step was to create 2 pieces of U-tape and test the charge of one of the pieces of tape using my hand, another U-tape, and a plastic pen/pencil. I then had to record the necessary data through video and calculation. Then I would create a computational model using data and various fundamental physical principles, and this computational model was used to illustrate what the predicted charge of the U-tape should be, including if it had an electron deficiency or too many electrons. I next had to compare the findings of the observed and predicted values, and based on those findings, I answer supplemental questions and make conclusions. The images on the right of this slide show the details of the experiment, including how to make the U-tape and myself making the U-tape, testing the U-tape charge by using a piece of tape, mechanical pencil, which would have the same properties as a plastic pen, and testing the polarity of the charge of 2 U-tape by floating one above the other. 4 important assumptions had to be made for this lab. The tape acts as a point charge with the charge in the center of the tape. Both U-tapes are the same exact size. There's no air resistance present, and atoms are square shaped in order to calculate area. In terms of the details of the experiment and initial conditions, the system of the experiment was the piece of charged U-tape, the surroundings were the second piece of U-tape, the earth, and pretty much everything else. Here's some of my initial measurements, including tape mass, tape length, tape width, tape surface area, the separation distance between the 2 U-tapes once one was floated above the other, the number of atoms on one piece of U-tape, and the charge of the U-tape and the deficient electron. The image of notebook paper below the initial conditions and details shows my calculation in finding all these values. The values of tape, mass, length, and width were simply measured using a meter stick, and the others were calculated. I found the charge of the charged tape by setting the electric force equal to the force of gravity, because I knew these forces had to cancel each other out in order for the system to be in equilibrium. After solving for the charge, I simply divided by the charge of an electron to find out how many electrons the charged tape was deficient of. After approximating the area of an atom and calculating the area of the tape, I was able to calculate the number of atoms on the tape, and by dividing the deficient charge by the number of atoms, I was able to see the ratio of how many electrons were deficient per atom. I do want to note that the notebook paper says electrons in excess, but that was just writing. So after conducting the experiment, I observed that the U-tapes repel each other. The U-tape attracts my hand. The U-tape attracts a negatively charged plastic pen/mechanical pencil, and the U-tapes on the tower repel each other. The free body diagram below sort of shows what the equilibrium would look like for the U-tape if it was a point particle or a point charge. You can see the gravity and the electric force are acting in opposite directions and they cancel each other out. That was the fundamental process I used for finding the charge of the U-tape. Here are the details of my computational model. I'm also going to include a link to GlowScript in the description of this video. So the first section are the constants, or sort of the initial conditions of the code. This is simply where I created variables for each of the values that I measured, and UPES is Coulomb's constant in this case. The next sections of my code are sort of the iteration of the code, or where the calculations that I did by hand, I also set computationally. I translated the equations for the electric force and the gravitational force into computational equations, and I outlined them with comments so you can sort of see where each one is located. And then if my work on the notebook paper wasn't very clear, I've also translated the equations for charge, deficient electrons, atoms, and the ratio of deficient electrons to atoms. And then the last 2 areas of the code, all the way at the bottom, are just what creates the point charge and the point charges and the vector arrows. And here's the image of the results of my computational model. Okay, based on the values I calculated by hand and those calculated by the model, they matched up pretty closely. So this means to me that the model accurately predicted the outcome of the experiment. And because both the observed and predicted results were matching, it can be concluded that the U-tape is in fact positively charged, has an electron deficiency, and had a balanced net force, so that the tape would float upwards. There could have been some errors, though. These errors include inaccurate measurements, including tape size, with the tape separation distance, rounding errors in calculations, incorrect calculations, or utilization of physical principles, misinterpreted results, and mismanagement of how the charge tape was positioned and how it was held. So there are two important questions that need to be answered for this lab. So if the charges changed whether they were positive or negative, the U tape would have been negatively charged. This would indicate an electron surplus, and the electric field of the point charge would point towards the tape rather than away. Next question. Handling the tapes as little as possible ensures no charges are transferred between objects. In other words, when charged tapes come into contact with other objects, they potentially obtain excess electrons, causing their charge to revert to neutral or maybe even negative.